Actually it is the day 3 of our class 11 organic chemistry. So here our topic is anti-Markovnikov's rule, or it is otherwise called as Kharasch effect or peroxide effect. So what is this effect and what is anti-Markovnikov's rule? So the rule itself says you that it is against to Markovnikov's rule. So in the last class we have discussed what is Markovnikov's addition. So addition of HBr to unsymmetrical alkene takes place through the Markovnikov's rule. So what is Markovnikov's rule? Negative part added to the carbon containing less number of hydrogen. So what is anti-Markovnikov's rule? So here Markovnikov's rule, negative part added to means negative part, as we are talking about in the peroxide. Peroxide effect takes place only in the case of HBr. So we'll take this negative part added to the carbon with less number of hydrogen, that is Markovnikov's rule. And so what is meant by peroxide? First we'll discuss that one. Peroxide means here, the example is here benzoyl peroxide C6H5 C double bond O C6H CO C6H5. Okay, this linkage we call as peroxy linkage. And here the point you have to remember is this reaction takes place through free radical mechanism. What is meant by free radical? Single electron species is called as a free radical. So this reaction completely takes place in presence of a sunlight. The breakage of this bond equally. One bond means here, one bond means 2 electrons. So here if you break this like with a homolytic cleavage. In the last class I have discussed about heterolytic cleavage, no? So homo means same, ante means equal distribution. Lytic means cleavage. Homolytic cleavage. So if you break a bond between these two oxygens, this bond pair of electrons is equally shared between these two oxygens. This takes place in presence of a peroxide, and this peroxide effect takes place through the free radical mechanism. Why here Br is added to the carbon containing more number of hydrogens? Because you remember the point here, free radical mechanism takes place via 3 steps. First one, initiation. Second one, propagation. Just briefly I will discuss here. And third one, it is termination. So here while it is proceeding through the free radical mechanism, here the first step is initiation, formation of a free radical. So here it is the example for the peroxide. It is the benzoyl group C6H5CO, benzoyl peroxide. Okay, it can be written on the arrow mark as C6H5 C double bond O taken twice O2. This is benzoyl peroxide. So first step, initiation, it is the homolytic cleavage. So if you break this bond, here this will get 1 electron and this will get 1 electron. So here what will happen? So I don't want to discuss the complete mechanism. So I just want to tell you that here as this is taking place through the free radical mechanism, you remember one point. During the propagation step, here there is a formation of a secondary radical. So because of the stability of the radical formation, tertiary radical, carbon radical is more stable than the secondary carbon free radical than primary carbon free radical. If it proceeds through the Markovnikov's rule, negative part added to the carbon containing less number of hydrogens, here this leads to the formation of a primary carbon free radical. But if we add Br to the according to this peroxide effect, actually it is the experimental analysis. After that we proposed a mechanism. These are the steps we have taken place. That experimental analysis was observed by the scientist Kharasch. So after the experimental observation, this is the mechanism proposed. Okay, this may be like this, or that may be like that, like this, by applying some rules. So here it may takes place through the free radical mechanism. Free radical mechanism means 3 steps. So here during the propagation step, here 2 possibilities which is leading to the secondary and primary. Here we got secondary carbon formation product as the major product, means maximum percentage. So this was the mechanism proposed. So if you are given with, this is observed only with the case of HBr plus peroxide. This is not observed in the case of HCl and HI. So peroxide effect only takes place in presence of peroxide. Peroxide effect only takes place if you take peroxide along with HBr only. So what is the reason for this one? During the propagation step, it leads to the formation of a secondary carbon free radical, so which is more stable than primary. So the addition follows. So addition follows opposite to, against to Markovnikov's rule. So it is otherwise called as anti-Markovnikov's addition. Okay, but here there is no formation of here the entire reaction takes place through the free radical mechanism. Okay, so now we'll discuss some examples. Same propene CH3, or you can take but1ene. Okay, 1, 2, 3, 4. If we take but2ene, it will become symmetrical alkene, no? So here if I take but1ene, it is to satisfy the valency of carbon. Just I am placing hydrogens. It is CH2 and it is CH. Here I am giving you 2 questions. First one, it is simple HBr addition, and the second one, here I am taking HBr along with peroxide, whatever may be the peroxide, and in presence of HNO. So write down the 2 products. So here first one, HBr without peroxide, follows Markovnikov's addition. Negative part, H plus and Br minus. How to write the product? I told you, no simple way of writing product. Just first replace this pi bond and write down the product. Here it is CH3 CH2 CH. It is CH2. Now negative part is added to the carbon containing less number of hydrogens. So you have removed pi bond between these 2 carbons. So HBr will be added to these 2 carbons only. So Br is added to this one, and hydrogen is added to this one. So it will become CH3. That is the simple way of writing product. So here the same HBr and the same alkene you are given along with the peroxide, no? So here in presence of a peroxide, what will happen? A Kharasch effect. Here it takes place through the free radical mechanism. Here Br free radical is added to this one. So here simply opposite to the Markovnikov's rule you add. So here Br will be added to the carbon containing less number of hydrogen, but you are given with peroxide. So Br will be added to the carbon with more number of hydrogens. Just for this also you replace the pi bond and write CH3 CH2 CH, and it is CH2. Here I have completely removed the pi bond, and Br is added to the carbon containing more number of hydrogen, and to the next carbon just I have added this one. So it is 1-bromobutane. So if you are given with the peroxide, this is the way of writing product, with the peroxide and without peroxide. Okay, clarified? Okay, we'll discuss another example. The same, here I want to discuss one point here. The same 1-butene if you are given with HCl, what is your product? So here you are given with HCl in presence of peroxide in the absence of peroxide. Here peroxide effect is not observed with HCl and HI. Peroxide effect is observed only if you take HBr along with peroxide. So in two cases it follows Markovnikov's rule. So what is your product here? If you are given with the HCl and peroxide, the same Markovnikov's rule, in both the cases the answer will be same. Clear this point? Okay. Make a note that peroxide effect is not observed if you take HCl with peroxide or HI with peroxide. This is only observed with HBr. There are many reasons to explain that. We'll discuss all those things later. Okay. But you, for your board exams, you try to remember these points. So this is, if you are given with like this, you will get the same product. Okay. Clear? So if you are given like this, so here same question, just here, if you are confused with this, so just at this one you place a carbon. Okay, so here you have 1, 2, 3 bonds at this carbon, so remaining hydrogen. Okay, so here 1, 2, 3, 4 around this carbon. So 4 bonds of carbon are satisfied, so there is no hydrogen at this place. So with HCl, whether it is a peroxide is not given or not given, the addition takes place through the Markovnikov's rule. Because peroxide effect is not applicable for HCl. So how to write the product? So simply here Markovnikov's rule, negative part added to the carbon containing less number of hydrogens. Among these two, this carbon has less number of hydrogens when you compare to this one. So here where you will add this one, here is your CH3, here is your CH3. You just remove that pi bond, add hydrogen here, and Br at this carbon. Okay, or simply you can write okay, and here also you will get the same product. Or if you confused with this, it is just simply CH3 CH3. This is the structure given to you. Now you add, sorry, it is Cl, no? Cl. So peroxide, CH3, CH2, CH3, CH3, Cl. Both are same. Okay. Now we'll discuss HBr and peroxide. Okay. So it is, what is the name of this one? 1, 2, 3, 4, 5. 3-ethyl pent-2-ene. How many carbons here? At the third place, ethyl group is there, no? So 3-ethyl pent-2-ene. If you give number like this, 3, 4, 5, then also it is 3-ethyl pent-2-ene. 3-ethyl pent-2-ene. Okay. So if you are given with this structure, if you are confused like with the structures, so you just carbon, 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 carbon. So carbon, 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 carbon. At the third position, here you have CH2, CH3, ethyl group, no? So here double bond is between 5 carbons, no? Between these two. So to satisfy the valency of carbon, you just place hydrogens. Here carbon valency 4 bonds satisfied. Here you have hydrogen. Here is your CH3. at the corner of your page, if you are confused with this type of structures, corner of your page you just like this 1 2 3 4 1 2 3 4. Okay, now HBr, what is the product here? HBr without peroxide, Markovnikov's rule. It follows Markovnikov's rule. Negative part of the carbon, negative part of the addendum added to the carbon containing less number of hydrogens. So here pi bond is between these two carbon atoms 1, 2 and 3. So to write the product you just remove this pi bond first. 1, 2, 3, 4, 5. It is your CH3, CH, and here is your CH2, CH3. Remaining hydrogens you place as it is, as you have just removed this pi bond. Here negative part added to the carbon containing less number of hydrogens, from where you are removing this pi bond between 2 and 3 carbons. So 1, 2, 3. So here at this place you have to add Br. It is your Br, and to the another place CH2. This is Markovnikov's rule. Here you follow anti-Markovnikov's rule. Negative part, free radical mechanism, no? So Br will be added to the carbon containing more number of hydrogens. So you just add Br to this carbon atom. Remove pi bond, add Br to second carbon atom, and to the third carbon atom you add hydrogen. That's it. So CH3, CH2, C, H, CH, Br, CH3, and here is your CH2, CH3. Okay, this is known as peroxide effect, Kharasch effect, or anti-Markovnikov's rule. Okay, so tomorrow I'll come up with one more topic. Till then, bye.